Hello everyone. Let's go through example 1 from the slide deck. Before I step through this example, I want to switch the inline primitives don't nest objects default view to render all objects on the heap Python view. You can do that by clicking on the drop down box at the bottom. Let me click on first. We are defining a function f. Then in line number 5, we are creating an integer object instance 10 and adding a reference to that into the variable num. So that's going to add an arrow from the num variable box to the integer object 10. In line number 6, we are invoking the function f by passing num as argument. Recall that whenever you're passing an argument, your parameter variable, which is x here, is supposed to reference whatever is being referenced by the argument variable, which is num here. When I click on next, that's going to create a new frame for the f function call, and we are going to have the x variable box include an arrow to the integer object 10 because parameter x is going to reference whatever the argument variable num is referencing, which is the integer object 10 here. Line number 2 says x into equal to 3. We are trying to update the value within the variable x to 3 times what was the original value. You cannot replace the integer object instance 10 with 30. That does not make any sense at all. You're going to create a brand new integer object instance 30 and you'll be updating the reference within the variable x to point to the new integer object 30. Now when I click on next, the print function call in line number 3 is going to display a value of 30 for x. Once the function call execution completes, the entire function call frame along with the local variables and all of the object instances that are only being referenced by the local variables will get destroyed. Since the integer object instance 30 is only being referenced by the variable x here, that's going to get destroyed when I click on next. So when we execute line number 7, that's simply going to print the integer value 10 because the num variable holds a reference to the integer object instance of 10 here. Let me switch to the slide deck. We are going to go through example number 2 next. Let me switch back to the browser window and paste the example. Observe that we now have a cluttered view because we are using render all objects on the heap Python. I'm going to switch that back to the inline primitives don't nest objects default view. Let's step through this example from the first. We are creating a function f by defining it. Then we are creating a list object instance which is storing two string object instances as items and adding a reference to the list object instance into the variable words. So you're now going to see an arrow from words variable which is pointing to the list object instance. Observe that the primitive object instances for the strings hello and world are directly shown within the list item positions here. That's because we are using the default visualization option here. So if I click on next, that's going to create a new function call frame for f. Then the items parameter variable is going to reference whatever is being referenced by the argument variable, which is words here. Line number 2 is calling the append method to insert a new item, which is the triple exclamation point, into whatever is being referenced by the items variable here. Recall that the append method call along with other method calls for a list sequence have an impact on the original value. So that's going to affect the original list object instance here. So now when I click on next, you're going to see a third item which is going to be item at index position 2. The item itself is going to be the triple exclamation point. When we execute the print function call in line 3, that's going to display the value of the items list as the strings hello world and the triple exclamation point. Now when I click on next, even though the function call f frame gets deleted, you're still going to retain the list object instance because there is a reference to that particular list object instance from the global variable words here. So because we use the method call to insert a new item here, that is having an impact in the original list object instance here. So now when I click on next, line number 7 is going to display the exact same list values as strings hello world and triple exclamation point here. Let's make one minor change to this example for going through example 3. Instead of saying items.append of triple exclamation point, I'm going to say items equal to items plus a new list which contains the triple exclamation point. That's now going to change the program's behavior entirely. Let's step through the program from the first. We are defining a function f, then we are creating a list object instance and storing the reference to that into the variable words. When we are invoking the function f, the parameter items is going to reference whatever is being referenced by the argument words here. Line number 3 here is creating a brand new object instance because we are saying items equal to items plus a new list here. So you're going to get a new list object instance which contains the 3 items. After that, you're going to update the reference within the variable items to point to the brand new object instance that you created for the list here. So now when I click on next, line 4 is going to display all 3 items here, which are hello world and triple exclamation point. After the function call f completes, the entire frame along with any of the object instances which only have a reference within the function call frame will get deleted. So this particular updated version of the list object instance is going to get deleted, and line number 8 is only going to display the values as hello and world within the list. That's because the words variable references the original list object instance which only contains the original 2 string items here. Very different behavior from what we observed with example 2. The difference comes in terms of whether you use the method called append here or add a new list object instance to the original list, which is going to create a brand new list object instance storing all of the items from the original list object instance and the new list object instance over here. I'm going to show you one more variation here, which is a very surprising behavior with respect to Python. Instead of saying items equal to items plus this new list, what do you think will happen if we say items plus equal to the list which contains the triple exclamation point? Observe that we are going back to the original version here where you're creating a sorry updating the existing list object instance and you're getting the exact same output from inside the function f. And after the function f execution, quickly stepping through this version, if I click on first and click on next, that's going to create a new list object instance pointed to by the variable words. When we create the function call f frame, items is going to point to whatever is being referenced by the argument words here. So if we say items plus equal to this new list item triple exclamation point, that's going to somehow update the existing list object instance. So with respect to objects and references mental model version v2, plus equal to is very different from saying items equal to items plus this new list. You just need to keep that different behavior in mind. I'm going to switch to the slide deck. I'll just walk you through the next couple of examples, which are example 4 and 5. I'm not going to step through these. Let me just paste it into Python tutor so that we can see the output. We have a function first here, which is returning the item at index position 0 within the parameter items. Then the function smallest is calling the sort method, and then it is returning the item at index position 0 within the parameter items. In the global frame, we are creating a list object instance and storing that into a variable numbers. The first print function call is calling first function and passing numbers as argument. Since the parameter items is going to reference whatever is being referenced by the argument here, that's going to simply display 4. So let me just step through and click on last here. So the very first function call for print is going to display 4. What happens when you execute the smallest function call? Recall that the sort method impacts the values in the original list object instance. So you're going to change the order in the original list object instance, and when you return items of 0, you're going to display 1. So when you call first function in line number 11, you're going to get the output as 1 here. That's because the original list object instance in the global variable pointed to by the global variable numbers within the global frame is going to get impacted. So let me switch to the slide deck and go through example 5 here, which is a small variation from example 4. Instead of using sort method call, we are going to use the sorted function call. Sorted function call is different. It does not have an impact on the original list object instance. So line number 9 is going to display 4 here, and line number 10 is going to display 1, which is the smallest number within the output from the sorted function call. When you're storing the result from the sorted function call into the variable items, you will only be updating the local variable reference items to the brand new list object instance that is created by the sorted function call. So in line number 11, when you call the first function, you're still going to display the value of 4 because the original list object instance never got updated due to the usage of sorted function here. Let me switch over to the slide deck, and we are going to learn about the double equal to operator versus the is operator. The is operator enables you to compare whether two object instances are exactly the same, which are being referenced by two different variables. Let's go through simple example for that. The variable w is storing the list object instance 1, variable x is storing the list object instance 2, variable y is storing the list object instance 2. Then we are saying z equal to y. This is going to be the visualization for this particular example. You're creating 3 object instances, but you have 4 references. The fourth one is going to be a copy of whatever is being referenced by the variable y here. So let's go through examples here. Is w equal to x? That is definitely false because those are two entirely different lists. What about y equal to z? That is very obviously true because both of those variables store a reference to the exact same list object instance here. What about x equal to y? That is also going to be true. That's because both of these objects store the same list item. So you're going to compare the items within the list object instance when you use the double equal to comparison. Let's learn about the S comparison operator. When you use the S comparison operator, you're going to literally check if both of the object instances are exactly the same, meaning that you're going to check whether X and Y are storing references to the same list object instance. So X is Y is going to return a value of false because X and Y are not storing the reference to the same list object instance. Y is Z on the other hand is going to return true because both of those are storing references to the same list object instance. This enables you to understand that when you make changes to your variable z here, that's going to impact the original variable y and vice versa. So if you were to say y dot append of 3 and display print of z, that's going to now display the list 2 comma 3. Be very careful with the s operator. Often you would need the double equal to operator instead of the s operator. Python performs something called as deduplication with respect to the s operator. When you consider this example where you're multiplying the string ha by a integer 10 and you're storing the result into two different variables, you would think that a equal to b will return true, whereas a is b will return false. That will work for this particular multiplier. What will happen if you were to change this number 10 by a value of 1? Try out both those examples using Python Tutor. I'll wrap up today's lecture here. We went through a lot of concepts. Please make sure to understand all of the associated concepts with objects and references thoroughly.